Today's lesson is 3.5. We're going to talk about shoe superstore. So who doesn't love their shoes? Solving percent problems involving proportions. So your learning goals today for this lesson: solve percent problems using direct variation and write an equation to solve the constant, to show the constant proportionality. So we're going to go back kind of to what we did in chapter 2, but we're using percents to show it. And then our key term today is, what is a commission? All right, read along with me as I read the introduction. When you go shop for food, does your family go to an individual store for each type of item you need? For example, do you go to a butcher shop for meat or a grocer for fruits and vegetables? Chances are that you probably make these purchases at a supermarket. Supermarkets brought convenience of multiple food items under one roof, and supermarkets also can offer big savings to food items by offering items on sale, accepting coupons on items, and offering rewards discounts for loyalty customers. In fact, most major supermarkets in the United States routinely offer discounts and sales on items weekly. How do you think supermarkets can continuously offer discounts and stay in business? Do you think supermarkets may be a reason that there are less specialized food stores that offer one type of food item? So just talk about that yourself and see what you think. I know from my experience, if you go to like places like New York City where it's very urban, they don't quite have these big supermarkets, so you do go to specialty shops a lot, like one place for your fruits and vegetables, one place for your meats, that kind of stuff. But usually around places like Louisville, you have Walmarts and Targets and Meijer and Kroger's and all that, and you kind of go to one place and get a lot of different things. And they are able to do that because they're huge stores, they buy tons of bulk, so they get things cheaper and they can offer you these discounts. All right, let's read problem one, Shoe Superstore together. The Shoe Superstore sells name brand shoes at a price much less than most department stores. The chart hanging in the store displays the normal prices of the shoes and the Superstore price. So in the left column, you have your regular department store price, what it would be, let's say at Macy's or something like that. And then you have the Shoe Superstore price, which is going to be, of course, a little bit cheaper because they said they sell theirs for cheaper. So think about maybe like Shoe Carnival or DSW Shoe Warehouse if you ever go to those type places. They tend to be a little bit cheaper. So let's answer question one. Do the Shoe Superstore prices vary directly? I would underline very directly with the regular department store price. Explain your reasoning. Okay, so go back to what we kind of learned in chapter 2. Is this a direct variation? Are these values proportionate? We have a table, so how do we determine if they're proportionate? Okay, so if you just divide one column by the other, you should be able to figure it out, right? So see what you can do and see if it's proportional or not. And then come back to the video to check yourself. All right, so number one, I hope you realize that this actually is a proportional relationship because the ratio is zero point 0.8 between the two amounts, or depending if you divided the other way, it'd be 1.25 for all prices. We're going to focus on the zero point 0.8. So if you divided 16 divided by 20, okay, you would have gotten 0 0.8. However, if you had done it the opposite way, if you had done 20 divided by 16, you would have seen 1.25. And if you do that for every row, you would have gotten those. So it doesn't matter which way you actually did it to prove that it is proportional. It is. We're just going to focus on this 0 point 0.8 and what that means between the regular department store and the shoe superstore. So most of you probably we usually think of our left column as like our X, and our right is our Y, and then we kind of divide that, but you could have done it the other way as well. All right, so let's look at number 2. Alfie claims that the relationship is not directly proportional because $20 pair of shoes is only $4 cheaper, while $50 pair of shoes is $10 cheaper at the superstore. So do you agree or disagree with Alfie? Explain your reasoning. So if you look back up at the chart, you see a $4 discount between the two. But then if you go up to $50, there is a $10 discount. So you subtract 50 from 10, you get the 40, whereas you get 20 minus 4 is 16. So do you agree with Alfie? Write down what you think and then come back to this video. Well, hopefully you disagree with Alfie. I'm not going to write all this down, but you should have written an argument such as, hey, Alfie, I totally disagree with you because it seems like you're confusing the dollar amount discounted with the percent off. So you really need to know the discount price is 80% off the department store price, which that is the direct proportional relationship. So if you go back up to this 0.8, remember 0.8 is really in percent, if you move the decimal 2 places, 80%. So the discounted price is only 80% of the regular. That's where you get your proportional relationship. You don't look at how do you get from regular department store minus some amount to the sale price. You got to look at the ratio between the two. Okay, now in number 3, define the variables and write an equation to represent the relationship between the department store price and the superstore price. So maybe we want to call the department store price, call it what you want. You can let it be D. Okay, and maybe you make shoe superstore S. And we just said it's 80% off. So how did you get from the, if you look back at your chart, how did you get from the discount, your regular over to your discount? Well, what did you really do? You're really multiplying by 0.8, right? Multiplying the discount price by your K, your constant proportionality or your unit rate of 0.8. So if we just said this is D, K is 0.8, and we'll times that by 0.8 to get our shoe superstore price. So that's our equation. So I wrote it 2 different ways. D times our 0.8 equals S, or how we do our Y equals KX format, I changed it to that. So S equals 0.8 times D. Okay, number 4. What is the constant of proportionality? Interpret the constant proportionality for this problem. Well, as you see right here, as we did our equation, we said that the S equals 0.8D, that's really our Y equals KX format for our proportional equation. So hopefully you realize that K equals 0.8, and that means that the shoe superstore prices are 80% off the department store prices. That's all it means. Oops, let me fix that. So again, that K times 0.8 just means the shoe superstore prices are just 80% off that department store price. Okay, at this point, I want you to use the equation we have, S equals 0.8D, to answer 5 and 6. You use that equation and then come back here and check your answers. Okay, so for number 5, hopefully you realize you're finding the shoe superstore price. So now in the equation, you're substituting in the cost at the department store of $28. You multiply that by your 0.8, your K, and the cost at shoe superstore would be $22.40. And then your reasoning, I didn't write the reasoning, but you should have written something like, well, because I know that the constant proportionality is 80%, I could use that equation to solve for S, and which represents the price of the shoes at the shoe superstore. And then in 6, what is the department store price? Again, you are just plugging in for D. So, for S, you know it's 15, and now you got to solve for D. Well, if we know that 0.8D, we got to divide by 0.8, not D. Let's fix that. Because we want to know what 1D is. Those cancel out. What you do to one side, you do to the other. And D divided by 15 is 18.75 or $18.75. So if you have discount shoes at Shoe Superstore at $15, at a department store you would pay $18.75. And you should have written for your explanation something like, well, because I know the constant proportionality is 80%, I could use that equation to solve for D, which represents the price of the shoes at the department store. All right, let's look at car commission now in problem 2. A car salesperson makes 10% commission on each sale. A commission is an amount of money a salesperson earns after selling a product. Many times the commission is a certain percent of the product. Okay, so complete the table to show the relationship between the price of the car and the commission the salesperson receives. So if the salesperson sells a $0 car, well, what's 10%? So times, remember, if we're going to do 10%, we got to multiply it by 0.1. Well, 0.1 of 0 is 0. Well, 9,000, we want 10% of that. Well, remember, our real quick rule trick is to move the decimal over 1 because you're dividing by 10 to get 0.1. So that would be 900 to get 10%. And same with 15,000. If you just take off that 1 0, move the decimal over 1 since you're doing 10%, or just multiply by 0.1, you get 1,500. Okay, now if you're going backwards, you're going to add a 0 instead of taking them away. All right, so this should have been your basic table of what you would have gotten. Now you're going to go and you're going to graph it, and you're going to come back and check yourself to see if you got your graph correct. Okay, I know this is by no means a perfect graph, but you should have kind of numbered somehow by like 6,000s on your price, something like that, and then maybe you went up by 300s on your commission, and you should have gotten this something like this, a line that again would have kept on going if we had more prices. Okay, let's move on and answer 3, 4, and 5 for problem 2. Define the variables and write the equation that represents the relationship between the price of the car and the commission received. So we want two variables, price of car and commission received. So maybe we call price of car C. I'm sorry, P would make more sense, I think. Commission would be C. Okay? Well, how do you determine your commission? Well, if we go back to our chart, here's price, P. We multiplied it by 0.1 to get our commission. So that's our equation. Take your price, multiply it by 0.1, and you get your commission. But, again, we don't like to write it in that format. So let's change it to our y equals kx type format. So C is like our y. That's how our outcome. Our independent variable is our price of the car times our k, 0.1. All right, how much commission will each salesperson earn for selling a $25,000 car? Use that equation and then answer 5. So if the salesperson earns $1,250 in commission, what is the price of the car? Do that on your own and then come back here when you're done. Okay, check your answers on 4 and 5, but basically you just plug into the equation and the known and solve for the unknown variable. Now in problem 3, we're going to move on to tips, taxes, and discounts. Number 1, a waitress received a tip, T, that varies directly with the bill, B. Suppose that T equals 0.15B. So that's like our y equals kx, that's our proportional relationship. 15% of the bill equals the tip. Okay, what percent tip does the waitress receive and how do you know? Okay, so think about that for a second. Well, if it's the 0.15, so they would get, change the decimal to percent, they would get a 15% tip. Okay. So now if we use the equation for 10, or for B, we know if the bill is $19, we've got to figure out that tip, so we need to know T. So if we multiply 0.15, our tip, times our $19, our tip would be $2.85. Okay, let's move on to C. Go ahead and answer that on your own and check back here. And I'd like for you to try 2 as well, 2A and B, and then come back here when you're done. All right, so hopefully for C you solved for B and the bill would have been $14. For 2, hopefully you came up with equation T equals KB, because they're just asking for a general, the amount of the waitress gets this T, and we know it directly varies with B. If we just let K be that constant proportion out and we don't know what it is, you would just make that equation T equals KB. We don't know what it is. So if they don't tell you the percent, you just work backwards. If they give you the bill and the tip, plug in bill for $30, tip was $6, solve for K, so you divide both sides by 30. That crosses out 30s on the K side, and the constant proportionality is 0.2 or 20%. Okay, so in C and D, I basically talked you through that. So hopefully you realize, I'll let you answer those on your own, but you should understand that the constant proportionality in this situation is the percent of the bill that Omar is going to receive for his tip. And for D, well, what is it? What is this constant proportionality? We figured that out already. It's 0.2 or 20% of the total bill. Okay, on 3 as well, I want you to go ahead and answer 3A and B. You're going to come up with your own equation this time using our y equals kx, but now you're using bill and T for tips, and then they give you your constant proportionality. You just have to change it from a percent to a decimal. Come back here when you're done. All right, so you should have come up with, okay, the tip is equals 0.18 of the bill. And in the B problem, it says, well, what if your bill is $54? Okay, so what is our tip? Well, if you plug in $54 for our bill, times that times 0.18, your tip would be $9.72. Okay, things are going to change just a little bit here in some of these problems. So in C, it says Marie receives a tip of $12. How much is the restaurant bill? Use your equation to determine that. So you just need to go back now and use your equation and figure that out. And then do D as well. If the restaurant bill is $12, how much is your tip? And stop there, and then we'll talk about E in just a second. Okay, so hopefully you plugged into your equation and you'd say, okay, well, my bill would be $66.67. My tip would be on D. If I had a restaurant bill of $12, it would be $2.16. That one was you just straight up multiply to get your tip because you're finding the part of the whole percent of a number. On E, you're working kind of backwards again. You're going to know that your tip T, plug in, is $3.20. But you don't know your bill, so you're going to divide by the 0.18. You divide 320 by 0.18, your bill would have cost you 17.78. And oh, does that not look good over here? I'll change that. So we're really dividing by 0.18. Okay, let's go to the next one. Okay, now we're going to move on to number 4. So hopefully you were able to use those equations pretty well and figure that out. Now we're going to go into taxes. So many states charge a sales tax on products you buy. The table shows the price of several products and the amount of sales tax added to the price in Pennsylvania. Okay, so what percent is Pennsylvania sales tax, and how do you know? See if you can figure that out, and then come back here and we'll talk about it. Okay, so hopefully you realize if you just take any one of those lines like 0.96 and you divide it by the cost, 16. Okay, so if you take the sales tax and you divide it, then you actually get 0.06, which is a 6% sales tax, which is what we have in Kentucky. Okay, so how much sales tax would there be on a $650 square flat screen? Okay, so let's use our y equals kx type format here. So we want to know the sales tax. So we'll just call it, I don't know, S for sales tax. So to figure that out, you're going to multiply your 0.06 times your cost, your original total, and your sales tax would be $45. So you would have to pay an additional $45 on top of your total price. Here's a challenge question that we're actually going to do in a little bit. What would the total price be after sales tax? Well, hopefully you realize, this is a little bonus question, that you would add $750 plus 45, and your total cost would be $795. That's what we're getting ready to do. That's kind of your second step. Okay, and C, if the sales tax on a lawnmower is $48, okay, how much is the lawnmower? So now we're going to work backwards. So they said, let C be the cost of the lawnmower. So if you know the sale tax is $48, so that's now our S, okay? We know our K is 0.06, but now we're trying to figure out this price of the lawnmower. So we're going to have to work backwards, divide by 0.06, and C is going to be 800. So this lawnmower originally cost $800 plus you would pay your $48 in sales tax, and you would pay a total of $848. All right, 5. We're going to move on to 5. This is the last problem, A, B, and C. Dexter's Department Store is having a sale with 33% discount on the merchandise. Write an equation representing the relationship between the regular cost of the merchandise and the discount received. Okay, so how are we going to write this equation? Let's say D is discount. So D is discount. What else is changing? Well, we could say we also know that the regular cost is changing. We'll just call that R. Okay? So we're going to call the D the discount and R is our regular. So we always take percent of the number to get our total discount. So we're going to end up with our discount, and we're going to multiply, since our discount is 0.33. Okay, we know it's that. And we multiply it by the regular cost to get our discount. That's our equation. Okay, now we're going to use that for the rest. So what is the discount on a pair of jeans? Okay, well, if you know that it's $50, how much is that discount? Okay, well, the discount is 0.33 times that original $50, and you get a $16.50 discount. Okay, here is an additional question. What would be your total cost here? We know the discount, but what would be the total cost? Well, hopefully you realize since the discount, you would subtract 50 minus 1650, which honestly, off the top of my head, what would that be? Pause and figure. So out of pocket, you'd be paying $33.50. Again, this part was just bonus down here, but that's real life. You figure out the discount and you subtract it off the total to figure out what the total cost would be. All right, so if a sweater has a discount of $9.90, what is its regular cost? Okay, well, we know that D now is discount. We know that it's $9.90. Okay, and we want 33% off that regular cost. We're trying to figure out what that regular cost is. So let's solve for R. Divide by 0.33. If you divide $9.90 by 0.33, your regular cost is $30. Now you're ready to go do some more practice.